Alright, so in this video, we're going to go over the 4.2, solving quadratic equations by graphing. So some of this might be review from last unit, or you might start learning it now. So this unit, you might have some questions that won't be in standard form. Everything won't be on one side. So in this unit, you'll have to make sure it's in standard form for graphing. So if you look at our first question here, the 6x squared equals 24. So standard form again, if you think about it, it's all in order, x squared, your x, and then your constant, and it's equal to 0. So everything's on one side. So what I'm going to do here, I'm going to move this 24 to the left side here, get it equal to 0. So the 24 minus 24, I know that's 0. Careful here when you combine these terms, it'll be 6x squared and then minus 24. So because they're not the same, you can't just combine them, so we're going to keep them separate. And that's all you have to do for that one. We're just practicing writing it in standard form. All right, the next one here. So there's two ways you could do it. The easier one for me is I would just add x squared to both sides. And so on the left side here, we'll get 0. And then here, I've had some students, they just write it like this. That's fine, but just make sure you put it back in standard form. So you want your x squared first, then minus 7x, and then plus 10. But you could jump from here to here. You don't have to write that middle step there. All right, so that one's done in standard form. Notice x squared, then x, and then your constant. All right, and then this last one here. So here, it's probably easier to move the x squared over because then I'd only have to do one term. But you could also minus the 9, add the x to both sides like this. So I'm going to do that just because I like keeping my x squared positive. So I'll have 0 equals x squared minus 9. Oh, whoops, nope. Sorry, plus x and then minus 9. So there, see how I just put it in standard form right away? You can do that. All right, so there, practicing just standard form there. Next part is something kind of new, but not really. It says use the graph to solve or find the zeros of the function. So we're going to take a look here. So the zeros, again, that also just means the x-intercepts or the roots. So the x-intercepts, hopefully you're more familiar with that term. Those are those x-intercepts right here. So there's two ways you could write it. Because it's a graph, I prefer to write it as a point. So it'll be 1, 0, negative 1, 0, and then 3, 0. Another way you could do it is you can put x equals negative 1 and then 3. But because it's graphing, I do prefer the points. For equations, if you put it as x equals negative 1, 3, usually that's when you do that. All right, so when you're given the graph, it's pretty simple. If you want to try letter B real quick, go ahead and do that. Pause the video. All right, so again, you want to identify the zeros or the roots or x-intercepts. So where is it hitting this x-axis here? So if you take a look, it's this point right here. So what is that point? It's going to be negative 1 again, 0. Or if you'd like, you can put x equals negative 1. So both are acceptable. The reason why they're giving you that equation is just the equation of the parabola. But there, you just want to find your zeros. All right, so on to these ones here. So this one we actually want to graph. So notice here, this problem we're going to have to actually combine a lot of things that we've learned. But notice that it's not in standard form here. So I'm going to have to subtract the 3 over on both sides. So I'll get x squared plus 2x minus 3 equals 0. And so the easiest way for me to graph this one is to put it in not standard form, factored form. So you might remember, you might not, but the factoring with the x, if you remember what goes on top, that's good. If not, it's a refresher. It's going to be a times c on top and then b on the bottom. So let's first find our a, b, and c. So a is 1, b is 2, and c is negative 3. So a times c is negative 3, b is just 2. So what you want to do for this one here is you want to find two numbers that multiply to negative 3, but they add up to 2. So here, if you think about it, those numbers will be negative 1 and 3. So here you could use the box, or some of you might just be able to tell because our a is 1, we could jump right to our factors. But let's just do the box in case you forgot. So x squared top left, negative 3 in the bottom right, and then your two numbers that you found earlier in the other two corners. So it'll be negative 1x and then 3x. Again, it doesn't matter if you switch the negative 1x and the 3x. So I like to look at these two here. What do they have in common? An x. So if this is x, on the left side here, you'll need an x times x to give us x squared. 3 over here to give us 3x, and then negative 1 to give us the negative 1x, and then double check 3 times negative 1 is negative 3. So our factors are x minus 1, x plus 3. So we can graph this here. If you remember, now it's in factored form. So a equals 1, p equals positive 1 as well, and then q equals negative 3. So the reason why we put it in not standard form, in factored form, is because now we know what our x-intercepts are. It's your p and q. So p is 1, q is negative 3, so we have those values here. So you could find your axis of symmetry. It'll be your p plus q divided by 2, so we get negative 1. Some of you could probably just look through and see that you end up getting it as negative 1 anyway. Now we want to find our vertex. So we're going to plug in our negative 1 into our equation. So I'm going to plug it into this one here, the one that we factored. So it'll be negative 1 minus 1, negative 1 plus 3. So what we get is negative 2 times positive 2, and so that's negative 4 here. So our vertex is negative 1, negative 4. So this point right here. So I know that seems like a lot because it is. For this unit, if you stop here and just kind of connect your points, that's totally fine for this unit because we're just trying to focus on the solutions. But I know before I would ask you to find some more points. So we would normally create our XY table like so. And just as a shortcut here, you'll just get 4, 1, 0, 1, and 4. So if you don't find these extra points, it's fine for this unit. But for graphing, I would like you to find the extra points. All right, so there's our graph. And so our solutions, again, are the x-intercepts, which we found earlier, your zeros. So it's going to be negative 3, 0, and then 1, 0. Or again, if you like, you could do negative 3, 1 as your answer, or x equals. All right, so we're going to move on to the next one now. So this one here, you might notice that there's only 2 terms. So there's actually something that we can do at the start to make things a little simpler. If you notice, what do these 2 terms have in common? They both have x's. So I'm going to actually factor out an x here. You'll get x on the outside times x minus 4. So this is technically in factored form now. It just doesn't look quite like it. But if you want to see it more clearly, this is what it would be. So our a here is 1 again, our p here is 0, and then our q is positive 4. So our x-intercepts here are going to be positive 4 and 0. If you can find your axis of symmetry right away, it's this value here, x equals 2. But if not, you could always do the work for it. So I'm going to plug it in, find the vertex. So I'm going to plug it into my equation here, 2 and then 2 minus 4. So you'll get 2 times negative 2 again, so it's negative 4. So our vertex here is going to be 2, negative 4, so go ahead and graph that. And so here, the points again, just going to be right one, up one, left one, up one, because it's a equals 1 like last time. So here's going to be your graph. So your solutions for this one here is going to be 0, 0, and then 4, 0. Or again, if you prefer, x equals 0 and then comma 4.